So in the last session, we had seen how to create threads. So I'll just do a brief overview, summary. So you have a program with multiple threads. You have thread T1, you have thread T2, you have thread T3. Now each thread has its runnable. This thread also has its runnable. Now remember, they can be different runnables, need not be same. And each runnable has its own run method. And we can create the thread with the runnable, or rather we have to create the thread with the runnable, and the runnable then describes its own run method, each one. And when I say T1.start, this run method will run. When I say T2.start, this run method will run. And this run method will run when I say T3.start. So we had discussed how to make this happen. Then we also saw how to wait for a thread to finish by saying T1.join, T2.join, and T3.join. Okay. Now this is where we stopped. I don't know how much of it you understood, but we'll pretend that most of you understood what we are trying to do. Now we are going to go into something more meaningful and something deeper. So what is it all about, this whole threading business? So you have a program, that is what we started. That program has a capacity to create as many threads as it wants. Let's say, for sake of example, 3 threads. Now each thread does its own independent activity. Each thread, what is dictated, as I just mentioned, by its run method. Now, these threads are in a program for a particular reason. There has to be some way, there has to be collaboration between this thread and this thread, or this thread and this thread. That means among these threads, there has to be some kind of an object or some kind of a data structure to which this thread can also communicate, this thread can also communicate, this thread can also communicate. Then only these threads can do what is called cooperation or collaboration. If these threads are each independent and there is no way they can connect with the same data structure, then there is no point in creating threads, because then somebody would argue, why did you create these 3 threads? Instead, you could have created another program and another program and another program. So why are we creating these 3 threads in one program? Each one of them can do independent things, that is all right. But they also must share something so that it is one unified task which these 3 threads are collectively doing. It's not independent. So that is why we are going to today discuss how threads can be created, that we saw last class, but how threads can together work as a unit and make things happen. So I'm going to build a small example. So I'm going to create another class. I'll call this class, for example's sake, as shared. This class is going to have some data member, let's say int d, and it is going to have 2 methods. Let's say one to put, there is a put method, and then there is a get method. What the put method is going to do? It is going to update d in a loop. So I'm going to say something like this: for int I equal to 0, I less than 10, I plus plus. I'm going to update this I. So what I'm going to do is, I'm going to say D is equal to D plus 1. So I'm going to write this in the for loop and update this D one at a time. Same thing in get, what I'm going to do, whatever this D is there, I'm going to return it. Now I may do it in a loop or I may do it one at a time. I think to get a better idea, we'll not write the loop. We'll just say each put, we can call it increment if you want. We'll keep enhancing this D one at a time from D to D plus 1 every time. And this get will return whatever is the current value of D. And this is the shared object. So now, for those of you who are a little slow, there is a data member in this shared object D, which probably starts with an initial value of 0. There are two methods on that shared object, increment and get. Increment just adds 1 to that D and get just returns that D. So that is what this class shared is doing. And after that, we are going to do this. Then after that, what we are going to do is, we are going to write a program, same program, where first we are going to create the shared object, S, as I just described. Then we are going to create two threads, for sake of example. Give this shared object S to this T1 also, this T2 also. So T1 is going to be getting this same shared object. T2 is also going to get the same shared object. And T1's run method, what is it going to do? It is going to do increment. And T2's run method, what is it going to do? It is going to do get. So there is a run method in T2. It is going to do a get. So this is going to keep on incrementing and this is going to keep on getting. So we have set up some kind of collaboration between these two threads, T1 and T2. And once this collaboration is set up, then we will see how we have to build some kind of synchronization mechanism so that these threads do exactly what they are doing. And what is that? The increment must happen, then get must happen, then again increment must happen, then get must happen. So this is how this process should go on. And how to make that happen. First we'll do it in a mistake, by making a mistake, then we'll correct it and you will understand why the shared object has to be protected and what is the meaning of mutex or locking or whatever to protect the shared object from simultaneous interaction by threads T1 and T2. So this in short is what we are going to demonstrate and understand how to do. Okay? So that being the summary, now we'll watch how to make this happen. So I've just given you an overall picture of what we are going to attempt and do. Watch it and if you can, type it along with us so that you understand how the flow is changing. So summarizing, I'm going to create two threads. One thread is going to do put or increment. Another thread is going to do get. My requirement is very simple. Even though I have two threads in my program, the first thread should not override the second thread. Meaning, unless the first thread increments, the second thread does get, then only this thread should increment. So there is this kind of a cocoa happening between two threads. He puts an increment, that guy gets an increment. Unless he gets the increment, this guy should not put the second increment. The thread should not go as if they are overwriting one after another. There should be an increment and then there should be a get. Again there should be an increment, then there will be a get. So how are we going to supplement this or how are we going to implement this? Let's watch and see how will we do this. So watch carefully. If you can, do it with us so that you understand the problem also. So we'll start with class shared. It will have one data member, int d, that is a data member. and then we are going to have a constructor in it. So it initializes D to some value. So it will take a parameter. So D equal to V. It initializes it to a value, that all you know. So I am creating a shared object. I am creating D equal to V, and I have initialized it. Now what do? Now there will be two methods on the shared object. One will be increment method, one will be get method. Get is to get the value, increment is to increment the value. Now watch carefully. Increment, what will increment do? It's a void method. Yeah, void method. So what will increment do? It will just increment D by 1. So D is equal to D plus 1. Okay. And what will get do? No, get will return a value. So it's not a void. Get has a return type. Okay. So int, and it will say return D. Okay. Done. Now I am summarizing this shared object. It's an object with two methods. One to increment the value, another to see the value, whatever the value is. So one is incrementing, the other is showing. So shared constructor initializes D to V, increment does D is equal to D plus 1, and get does return D. That's all. So now I am going to create two runnables. Why am I creating two runnables? Because I have two threads. Each thread I want to do different things. If you want all the threads to do the same thing, then one runnable is enough, or the same runnable is okay. But I am not doing that. I am creating, because one thread has to do the incrementing, the second thread has to do the retrieving. So we can't have the same thread, the same runnable for both the threads. Because runnable gives the body and soul of a thread. Every thread has a soul. What is that soul? What is it that the thread should do? So that is its run method. How does a run method come to the thread? Using its runnable. So we'll create two runnables. So class myRunnable and class myRunnable1 and runnable2. Then we'll write the body for the runnable. So we are creating two runnables. So class myRunnable1 implements runnable. Class myRunnable2 implements also runnable. Unless you implement runnable, it is not recognized by the thread as a runnable. So remember, wait. Okay, you wrote already. No, runnable has one method. It's a standard interface provided by Java, just has one method, public void run. So if I am implementing a runnable interface and I don't want to be an abstract class, then I must implement the runnable interface, which is provide body for the run method. So I am saying class myRunnable1 implements runnable. Now I have to provide the body for the method. So I am writing public void run, and in that, now this runnable, okay, let's give it a better name than myRunnable. So let's call it class producer, because it's going to produce data. It is going to increment data. So I am not calling it myRunnable1, I'll call it producer. The second guy, I will call it consumer. Yeah. So we have a producer thread, producer runnable, and we have a consumer runnable. So in the producer runnable, what I'll do is, I'll write a loop here, but before that, remember, the runnable needs a shared object. See, the producer and the consumer, they are both going to work on the shared object. Now here is where a lot of people don't understand what is going on. Okay, if you have understood so far, now comes the critical point. See, how many threads are there? Two threads are there. Each thread has its runnable. Now, each runnable or both the runnables have to work on the same shared object. if they have to work on the same shared object, how many shared objects will I create? Only one. And I will pass this shared object to these runnables. So I will create one shared object and I will give it to both the runnables and say, Mr. Thread 1, you work with this runnable. Mr. Thread 2, you work with this runnable. So both these runnables are going to work on the same shared object. If I give two different shared objects, it is like one guy works with one, the other guy works with another. It is called looking London, talking Tokyo, meaning they have no connection with each other. That is not what we want. What we want one object, and we want that object to be simultaneously operated on by two threads. There is only one object, shared. That object has to be given to both the threads so that both of them can act on that object, one to put or produce, the other to display or consume. So in order to make that happen, I must find a way of giving the producer the shared object and giving the consumer also the shared object. So in my producer, I must write a constructor, and I should have, go ahead, keep a copy of the shared object in the producer. So shared S. Shared S. Now how will the producer get this? Via its constructor. So the constructor of producer must get a shared object which it must keep with itself. Otherwise, it will not know on what shared object it has to work. So now I am writing the constructor for the producer. So producer shared S1. In the producer, I am taking a parameter called S1, which is of type shared object, and using it to initialize S. So I have initialized S equal to S1. So my producer is going to get a shared object. Now, in the run method of the producer, what am I going to do? I am going to work on the shared object. I have got it in the constructor. So whoever creates me will give me a shared object, and that shared object in my run method, which is the body of my method, I will run on that. I will work on that. So let's write a loop there. So we'll say for int I equal to 0, I less than 10, I plus plus. So what will we do there? In the shared object, on the shared object, we will write the increment method, because our job is to produce. Okay. So this is my run method of the producer. So look at the producer. Just look at the anatomy of the producer. It has class producer, implements runnable, because without which thread can't use it. So we are implementing the runnable interface. It has a variable called shared S. It has a producer constructor which is used to receive the shared object. And in the run method, 10 times we are calling the increment method on the shared object. The shared object has two methods, increment and get. So the increment method is called 10 times. Okay. Now slowly it will start making sense. Now we'll create the consumer. Okay. What will the consumer do? It also has to get a shared object. So I also have to write a constructor for the consumer. So again we declare the variable, then we say consumer shared. Consumer also takes a shared object as a parameter. Shared S1. So same S1, you can put S1 again. No. Same name, what? S is equal to S1. Yeah. So I created the consumer. Now shared object is there. Consumer is passed the shared object. Now we'll write the run method of the consumer. So the run method of the consumer will do what? It will do the get. It will also do 10 times. So for int I equal to 0, I less than 10, I plus plus, we'll just say SOP it will print the value on the shared object. So it will say s dot get. Okay. Now once again, we are now about to write the last class, which is main test. So I'll go up just for sake of completeness. I have class shared. Now class shared has a constructor, has two methods, put and get, or increment and get, and they work on that D. Done. Come down. Then I have a producer which implements the runnable interface. This is going to be used by the producer thread. And then I have the, what does the producer have? In its constructor, it receives a shared object and initializes its S to that shared object. Then it has a run method, and in the run method, it calls increment 10 times on the shared object. That is a producer. Then we have the consumer. Consumer also gets a shared object in its constructor, and in its run method, it just retrieves what is there in the shared object 10 times and displays it. So now we come to the crux, which is the main. Now watch carefully, try and understand main. If you understand it first go, fantastic. So public static void main string args. Now how do you think I should start this? Should I create the producer first, consumer first, or shared object first? Obviously I need to create the shared object first. Why? Without that I can't create the producer, I can't create the consumer. We just wrote the constructor for producer and consumer. Both of them need a shared object as a parameter. So how many shared objects should I create? One or two? One. If I create two, give one to this guy, give another to that guy, there is no connection. This guy will do something, that guy will do something. That is meaningless. It should be on a single shared object, both the guys should work, right? So now first I'll create the shared object. So shared S new shared, I think it starts with some value. Let's say the value is 5 to start with, because the constructor takes some initial value. So I created the shared object. What do you think is my next step? What should I do? I should create the runnables, because I can't create the threads without first creating the runnables. Threads can't do anything. They don't have a soul. If you have to give a soul to a thread, you have to give a runnable. So the runnables run method becomes the soul of the thread. That is what the thread is going to run. If I don't have a runnable, the thread is empty. He exists without any work. Okay? So we'll do that next. So we'll create the producer thread. So create a producer. Producer P is equal to new producer. And to the producer, remember it needs a shared object as a parameter. So I'll pass S as a parameter. So I have created the producer runnable. Now I have to create the consumer runnable. So consumer C is equal to new consumer. Again I pass the same shared object as a parameter. So I have created the producer, I have created the consumer. Now producer and consumer are fine. So I have my runnables in place. I have created my runnables. But where are the threads? There are no threads. So I have to create the threads. If I don't have threads, I don't have nothing, right? So we will now create the threads. So thread, let's call it T1, or shall we call it something better? Okay, so we'll call it PT, producer thread, is equal to new thread. And remember from last class, a thread cannot be created without a runnable. So I need to pass a runnable as a parameter. Now, I'll pass that runnable P to the first thread. So now the thread object PT is instantiated. Then I'll create the second thread, CT is equal to new thread. Now new thread with C. Okay. So I have now created two threads. One is called PT, other is called CT. If you look at line 41 and 42, the first thread has been created with P as a runnable, and second thread has been created with C as a runnable. So P is the producer runnable object, C is the consumer runnable object. And now I need to say something simple. What do I need to say? You remember last class? Just creating threads doesn't do nothing. What do I have to do? I have to start the threads. Unless I start, they don't run. I have to start. And then I can wait for them to finish by putting a join. And join, remember, throws a checked exception. So I have to report the exception or catch it. Okay? So let's write all that circuit. So pt.start, ct.start. Now, we'll wait for those threads to finish. Throws interrupted exception. We are writing it so that we can use join. Without this, we can't use join, because join is a checked method, is an method which throws a checked exception. And because the checked exception is there, you either have to report it or you have to catch it. You can't do both. You can't escape both. So now we will say pt.join. So I'll wait for pt to die, and ct.join, I'll also wait for ct to die. Yeah, and then I will say out of main, something like I am done or something. So end of main. I am done. Very good. Okay. So we have written two threads. We have created two threads, each with its own runnable. One is going to do increment, the other is going to do decrement. Get. Now remember, what was our original reason? Every increment should be retrieved, then the next increment should happen. Will that happen? No, because we have created two threads, they are doing independent activity, and let's just understand and run them and see what really happens. Okay? So then we'll correct it, and while correcting it, we'll learn something very important. So watch. Yeah. Okay. Do you know what happened? Anybody figures out what happened? Why am I getting a bunch of 15s? Remember, initial value was 5. What must have happened? Anyone? What do you think happened? Something happened, no? What happened? The increment thread, that is the producer thread, ran how many times? All 10 times. The consumer thread never got a chance to run. So it finished, and then the consumer ran, and consumer ran how many times? Again 10 times, because we wanted it to run 10 times. And what did it do? It produced 15, 15, 15, 15. What was our expectation? How should it have come? 6, 6. I mean, the producer should produce 6, the consumer should print 6. Then the producer should make 7, consumer should display 7. That is what we wanted. What have we got? The producer thread has gone on, the consumer thread has then started and produced 10 times 15 value, which is hardly the issue. That is not what we want. We never wanted. This is like single threaded only. At one time only one thread is running. What we want? Producer, consumer. Again producer, consumer. This synchronization is what we wanted. Then the threads are doing something collaborative. If this was my objective, I don't need multi-threading. What can I do? I just do 10 times increment. After I am done, 10 times I can do display. For that, why do I need threads? Waste of time, waste of effort. So threads by themselves don't solve anything. Threads, when they work collaboratively, then threads do something useful for us. Right now, they are not doing anything for us. Right now, one guy is just doing on his own, the other guy is doing something on his own. Waste, correct? So this is what is lacking. Our program has threads all right, but our program doesn't have how to collaborate threads, how to build harmony among threads, how to ensure that one thread does something, then the other thread does something. Now in OS, you have done OS or not? In OS also you'll learn this. This is called semaphores, or we call it mutexes. Same idea. There we deal with processes, that is programs as a whole. Here we deal with threads. But the idea is the same, that you have to support mutexes, which is called mutual exclusion. One guy is doing, the other guy should shut up. Other guy is doing, this guy should shut up. That is what we want. In OS we'll call it mutexes. In threads we'll call it synchronization. We'll see how to do it. But before that, let me summarize. What should happen? The producer should do one production, increment, then he should shut up. You are with me? Then consumer should act. And while the producer is doing production, the consumer should not do anything. And vice versa. While the consumer is consuming, he shouldn't do anything. Producer shouldn't do anything. Okay, now, this is not going to be easy. It's going to be one step at a time, and there will be a little difficulty to understand. But let's see whether we can get those ideas in. The reason I want to do this quickly is because, in Java now, this is one threading model. We have to learn this threading model, and then we have to learn the next threading model, which is what is called the promise threading model, which is new. So we have to finish this fast. So let's see whether we can get you that idea. Okay. Now, what I'm going to do is, before doing something, I'm going to add a little more flavor. Okay. Just to illustrate, I'm going to make my increment become very slow. I'm going to slow down my increment. Now, and also get, how am I going to slow it down? I'm going to put sleep. I'm going to make my thread go to sleep while doing increment. Just to slow it down, just to give you the feeling that increment is a big operation. In real life it may be, but just so that we can simulate a delay, I'm going to make the increment slow. Okay, that is the first step towards understanding. So we'll go to increment method, and in the body of the increment method, we will write thread dot sleep. Thread has a static method called sleep. Sleep takes a argument in milliseconds. So it's always in milliseconds. So we'll make it sleep for a second. Okay, so 1000 milliseconds. So I'm going to slow down inc, okay, and I'm also going to slow down the retrieval. So I have slowed down increment, I have slowed down sleep also, retrieval also. Now let's see whether it has any effect on our working, and observe. Okay? Then we'll change something more. So what are we doing? Earlier 2 threads were there, now also 2 threads are there. Earlier, one thread was producing, now also it is producing. The other thread was consuming or displaying, it is still doing that. What has changed? Production has slowed down. You are with me? Production has slowed down and consumption obviously has also slowed down. So let's see what happens. Okay. Now I get an error. You know why I get an error? Sleep, if you look at the documentation, also has a method which throws a checked exception called interrupted exception. Same problem. All these methods, join, sleep, whatever, they all throw this interrupted exception, which happens to be a checked exception. So you have to be careful that you have to report that exception. Okay, so we will make our inc smarter. Inc throws interrupted exception, and get also throws interrupted exception. I hope you guys are doing as we are doing, otherwise you will lose the context. So I have slowed down increment method, get method. Now again I will get a compilation error because inc is throwing interrupted exception, which is checked exception. Now you will get compilation error again. Let's get them again so that we know why we are getting them. Yeah, so the guy who is calling this also will get interrupted exception. So because it's a checked exception. So let's go back to the code. Now in run method, where I am calling inc, that time inc is coming out with a interrupted exception and run is not doing anything. So again I have an option. What I can say? I will say in run throws interrupted exception. Then I'll have to allow main also to have it. Instead, let's catch it now. Let's not keep ducking it. In run, let's catch it. Okay. So we'll put this in a try block and we'll put a catch block. Catch interrupted exception. So in both the run methods, we will catch the interrupted exception. So when you catch it, you say SOP done. So we corrected our run method, we caught the exception. Now we'll have to do something similar in our consumer method. Again we'll say i.getMessage. Okay. Since we have done some work, I think I'll just do a summary before I go to the execution. Okay. Our compilation error will go now, but I think it's time we summarized what we did. So we are creating a program P1. In the program P1, first we are creating a shared object S. Then we are creating a producer runnable object, or we are creating a producer. Producer is given this shared object. Then we are creating a consumer. Consumer is also given the same shared object. So the producer and the consumer both have their own, have the same shared object, which was created by the program. Now the producer has a run method via the runnable. Consumer also has a run method. This run method is calling inc 10 times, and the consumer is also calling get 10 times, and we have managed to slow down this ink, sleep, and sleep here also. So, now let's summarize what is going to happen. The ink method is going to be called 10 times by the producer. The sleep method is going to slow it down. So it is going to produce first 6. Then, because it is sleeping, to do the retrieval, because this guy is sleeping, he is going to produce and is going to go to sleep. So the get method is going to get 6, okay, and this process will go on. So then hopefully he will, it depends actually. So 7, maybe. Let's see what we get, okay. So we are going to see the output. Output may be completely unpredictable, but let's observe what we get. Okay. We are getting fairly consistently values. If you notice, now do you understand what happened? So I don't know what happened to 6. 6 should have come, no? Or it's lost about. Started with 7. Why? No, it should run it again. No, it's starting with 7. Anybody got 6? Yeah, you should get 6 also. I mean, it's unpredictable, that's all. Huh? Oh, I incremented before, is it? I incremented and went to sleep. Now, would that matter? I don't think that will matter. Sleep, Baba. No, I don't think that should matter, no? Let's see. It got, huh? Okay, now we get 6. So I produced a value, went to sleep. Correct. So it gave an opportunity to the other guy to consume the value. Now you notice, what have we done? By slowing down the production, what is the producer doing now? Producing a value, going to sleep. Giving the other thread an opportunity. When this is going to sleep, remember there are 2 threads in the program, actually 3. Forget the main thread. The main thread is waiting for the child threads to die. That's all it is doing. So forget them. So what is happening? The first thread is starting, the producer thread. Then it is producing a value. Then it is going to sleep. By doing exactly this, sleeping, it is giving a chance for the consumer to take the value. But this is by chance, and sleep is not a good way of doing things. See, it's like saying, I'll produce a value, then I'll go to sleep. So because I'm going to sleep, you get an opportunity to run, and you consume the value. So you are getting 6, then 7, 8, like that it is happening. But a lot of people may be tempted, why do I need anything else? Just make the thread slow and it will produce the output. Okay. Now, this is a very stupid way of doing things. Okay? This is not how it should happen. Okay, now I'm going to show you something else. Now, we are doing very slowly, step by step. Now, what is our rule? While the increment is going on, the get shouldn't happen. That is our foundation rule. What did we achieve this? By putting this thread to sleep. But that is not the intention. The intention is somehow while INC is going on, get shouldn't happen, and while get is going on, INC shouldn't happen. Here, what is happening? One of them is happening and is going to sleep. And because he is going to sleep, the other guy is getting an opportunity to run. That is like a roundabout way of achieving synchronization. Now, I am going to show you a little more addition to the code and you will understand what I am trying to say. Okay? So, I will go to the increment method and put a SOP before that at the beginning. Entered ink. Entered INC. Then I will say at the end, exited INC. Please watch carefully what we are doing. We'll give you this code, but don't wait for it. Try to execute it on your own first. So, now see the change I have done. In INC, I have said entered ink before entry, before going to sleep. Then I have said exited ink. Okay? So, the ink method, which is going to be called 10 times by the producer, is announcing to the world, I am entering. It is also going to announce to the world, I am exiting. Okay? Same way, the get method will announce, I am entered get, then I have exited get. Watch. So, entered get, and then I will say, yeah, exited get, entered get, exited get. Okay, entered ink, exited ink. Now, I am going to show you, watch carefully, what is really happening, because it wastes time, it doesn't do synchronization. Don't use sleep. I am showing sleep only to show you this is how it will happen, just to illustrate sleep. Now, observe what is happening. Okay. Yeah. We have to analyze this in detail. Okay. Let it come and then we'll illustrate. Now, we'll go up. Just say Control C. Just wait here. Now, please observe the behavior. So, it entered get. I have no problem with that. So, this by itself is not a problem. The thread came, it entered. I have no problem with that. Now, the problem is, while get is going on, how did it do? Entered ink. Now, why did it happen? Because entered get did something and went to sleep. That gave an opportunity for the other thread to do the entering ink. Then, after some time, this guy went to sleep and this guy then exited get. Now you notice, now you have to observe this very carefully, please. Entered get, because of the sleep, I said, ink got an opportunity. Then exited get and exited ink. Now, our argument is, that while ink is going on, however slow it may be, ink, however slow it may be, okay, I have intentionally slowed down ink and get. So while ink is going on, however slow it may be, the get should not get called, should not be called. Only if I am able to implement this will my code run consistently. Here, I have intentionally slowed down ink by putting a sleep, and I have intentionally slowed down get by putting a sleep. But for proper synchronization to happen, while the ink is going on, however slow it may be, get shouldn't happen, and vice versa. But is that what is happening here? Now, if you observe the output, you may get a slightly different output, doesn't matter. But if you see, entered get, before get was exited, how did ink got entered? This shouldn't have happened. Obviously, because we have not done any synchronization, so I'll try and summarize this on a page. See, try and understand, please. This is important. There are two threads in action. Okay? There is a shared object on which ink is happening and get is happening on this shared object. Both are working on the same shared object. One guy is doing ink, the other guy is doing get. Each is called 10 times. It does not matter how many times it is called. Now, while ink is going on, we have put a sleep in both, just to simulate that these guys are slow. Now, while ink is going on, I don't want get to happen, because till ink is over, the data may not reach consistent state. In this example, it is very simple, in one value. But in a real life, this ink may do lot of complex operations, and while it is operating, this should not operate on the same shared object. That is what I tried to do by creating a sleep, to show that ink is doing lot of work. But what unfortunately happened is, the moment this guy went to sleep, this guy decided to run. Moment this guy goes to sleep, this guy decides to run. He gets an opportunity to run. What should happen? What was my intention in putting sleep? Just to demonstrate that ink is a complex operation. It will take a long time to complete. That is why I put the sleep here. But the putting of the sleep enabled an opportunity for this to go, do a get, and we got the answer. Now, this is not what should happen. Okay? So, now, this is what is happening. So, what should be done? Now, please follow me carefully. Somehow we have to tell the thread T1, while you are working, I will not work. While you are working, I will not work. This is called in OS, what is this called? Mutual exclusion. When I am in the room, you don't enter. When you are in the room, I won't enter. Is that what is happening now? No. No. While one guy is entered, before that guy is exited, the other guy is entering. Watch again. With this background, watch the output again. We'll run it again. Yeah. Okay, now watch the output again. I'm going to run it again just to demonstrate. Oh, good. Okay. So it said entered get. Now, it said entered ink. That is where the problem is. Watch this. It said this, then it said this. This shouldn't happen. Entered get, exited get, then entered ink should happen. Then it is correct. So output should have been entered get, exited get, then entered ink, exited ink. So this will demonstrate that while get is going on, ink didn't happen. While ink is going on, get didn't happen. Now, this can happen before this. I have no problem with that, no quarrel with that. Because it depends on which thread gets called first, the producer thread or the consumer thread. Either one of them can get called first. I have no issue with that at all. My issue is entered get, entered ink should not happen. Entered get, exited get, then entered ink, exited ink, then only entered get again. There should not be any intermingling of these. Now, I am going to use a single word. This is the beauty of Java. I am going to use only one word. I am going to just put one keyword and you will see automatically I will get mutual exclusion between the two threads. Just one word. What is that word? Anyone knows? I am going to use one word so that this guy, until he is finished, the other guy won't come. Until that guy is over, this guy won't come. Okay, the operative word is called synchronized. Now, just see what I am going to do. I am going to go to the ink method and mark it as synchronized. What does synchronize mean? Some other thread is working on this object, or, okay, just watch first, then I will tell you what happens. Okay? Again, get also, I will mark it as synchronized. The keyword in Java, this is the whole reason, the whole build-up, what we were discussing so far, is just so that you understand what synchronized does. First watch it, what it does, then we'll try and explain what is happening. Okay? Watch this. Okay. Now, watch what is happening. Okay. Did something change? No, yes. Okay, we are not still close to perfect. We'll come to perfect little later. But do you understand at least what happened? While increment is happening, retrieval is not happening. You notice entered ink, exited ink, entered ink again, exited ink. Okay. So now the first thread is running, increment thread is running. What is it doing? It is producing the first number. While it is doing something, the other thread doesn't get a chance. Then this thread is doing again all it is doing. Now, though I am sleeping, I am not giving a chance to the second thread to do anything. Okay? I am sleeping all right. I am waiting and doing it 10 times. Okay, now what happened? Okay, let's observe. I'm going to draw it differently and show what really happened. Okay, please watch and understand. So I have now two threads T1, T2. I am drawing this repeatedly so that you will understand. So I have a shared object. T1 is a shared object, T2 is a shared object. T1 is given the same shared object S, T2 is given the same shared object. Now, T1 is calling in a loop of 10, it is calling on the shared object S dot increment. And T2 is calling again in a loop of 10 S dot get. S is the common shared object, this shared object. It's calling ink, it is calling get. Now, what is happening? Okay. While the ink is going on, there is a sleep. There is a sleep. And now this method, ink, is marked as synchronized. And the get method also is marked as synchronized. Okay. So this is marked as synchronized, that is marked as synchronized. Now what will happen? So the moment s.ink gets called, this, okay, let me use a different color. The moment s.ink gets called, this object gets locked. And how long the lock will remain? Till he wakes up of the sleep and exits this method, it gets locked. After that, okay, during that time, while this object is locked, now you'll ask, why is it getting locked? Whenever you call a synchronized method on an object, that object gets locked. How long will the lock remain? Till the duration of ink. Till ink is over, this lock will remain. Now, the get is getting called, all right, and this thread is running, because while it is sleeping, this thread is running. But what is happening? When it tries to do get also being synchronized method, it says, give me this object, but I want it unlocked. What has happened is, for synchronized method to execute, the object should be first unlocked, he will lock it, and then he will proceed. And at the end of the method, he will release the lock. Now what is happening here is, because this method got the object first, it so happened that this guy got called first, he locked the object. Though this thread got scheduled, he tried to call the get method. The get method, what did it do? It tried to lock the same object, found that this guy is locked, went to sleep. Again, how long it will come out of sleep, again try to do the get or whatever in that loop. So it will say, I again can't do anything because the object is locked. So it so happens now that this is getting called 10 times, but each time the object is getting locked. And while it is getting locked, though this guy is getting called, he has no other option but to wait, because the thing is synchronized. Okay. Now you may wonder, okay, what is happening? Let's go back to the code. Okay. Now let it run for some time and we'll observe what is the output. Rather than stopping in between, let it run its own story. Now it has run 10 times. Till then he never got an opportunity to run. Now he is getting back to square one. Again we are getting 15. Because the producer has run 10 times and now the consumer is running. So consumer may run now any number of times, it will always get the value 15. Okay. So this is the code we have so far. So what all we have done? Okay. Okay, let's go to the increment method again. Now let's focus our attention on increment and get methods. So see the increment methods. Now increment methods are saying entered ink, going to sleep, then saying exited ink, going to incrementing the value and saying exited ink. Okay. And while they are doing their work, the get will not get an opportunity because ink, because of the word synchronized over here, this word and this word, while they are acting, this object is going to remain locked. So this ink is going to be called 10 times. First time it is called, it is locked. Now, though this guy wakes up the consumer, because synchronized insists that I need a lock on that object which has been locked by this guy, and that's why this is coming. Get is not able to get till this guy is done. Now, we'll try and change this. We'll remove the sleep. Both these sleeps will remove. We put the sleep only to delay. Okay, now observe what is happening. Let's get rid of the sleep. We'll comment it, don't remove it. We have commented sleep. Okay. Okay, now before we run it, let's see, analyze it, and then let's run it. Okay, we are analyzing it, then we'll run it. Now, I have thread T1, thread T2, shared. This is calling increment method. This is calling get method. So the increment method is going to be called 10 times. Let's not worry about it. Is going to say entered, exited, entered, exited. Now, because these methods are marked synchronized, while this is going on, this can't go on. Okay. Now, we are closer to our solution, but we are still a couple of steps away. So, let's observe what happens. Okay. Yeah. Now, no. Okay. And we'll try to see, control C quickly, because there is no sleep, it will run very fast. Okay. Now, we'll try and you may get slightly different output. Now, I am not able to show you what we got earlier, but mutual exclusion is still happening. So, what happened now? Okay. Let's analyze. We are still getting 15, please remember. So, now we are coming to the final solution, but I'll go slow. Okay. Now, again, now some of you will lose attention, please don't. So, I have the shared object, I have increment, and I have get. So, what has happened now is mutual exclusion is happening. While this is going on, this is not happening. But because there is a loop here, this is happening 10 times, and then this is happening. While this is going on, this is not happening. That is for sure. Because we are never seeing intermingling. Okay, we'll reduce the thing to 3. Okay, just let's make a small change. Instead of printing it 10 times, we'll just print 2 times. No, go to the code. Okay. No, not here. Here, we'll just change it to 2 times, 3 times, okay. Both places. So that we can see the output on our screen. That 10 times is going beyond. Okay, this is better. So, now observe the output. Now watch what we got. So, entered ink came, exited ink came, entered ink came again, exited ink came. So, this made it 6, it was at 5, so this must have made it 6, this made it 7, this exited ink, entered ink, exited ink, this made it 8, okay. Then entered get, exited get, we got 8, entered get, exited get, again we got 8. Entered get, exited get, again we got 8, and I am done. So this is what happened. While this guy was going on, while the put was going on or producer was going on, the consumer never got a chance to run. That is a good part. Though we have removed sleep. We have removed sleep, please remember. Though we have removed sleep, while this is going on, this did not happen. Only when producer was over producing it 3 times, the consumer got a chance to run, and because by that time the producer had already gone up to 8, the consumer got 8 3 times. That should not have happened. But we have achieved one step, which is what? While the producer is going on, though it is not sleeping, the consumer is not getting called. That is a necessary step. Why did that happen? Because of the synchronize. While this guy was doing work, this guy didn't do any work. This guy couldn't do any work because this guy had kept the object locked. And then this guy did the work. It was releasing in between, but when it was releasing, this guy was not running obviously. So he exited. He entered only after this guy finished. Okay. Now we are going to wait here. Okay. I think if I go too long, I lose everyone. Now I am going to give you this code, and we are then going to change this code in the second session. I'll give you a break. We'll wait 15 minutes. Then we'll come back and now make a change. Meanwhile, please, if you can, run this, understand what is going on, and this will be the change for the next step. So we'll give you this code as it is. So please take this code. Please look at the program once. We'll again go through it. I am hoping that you will understand what is going on. And then we will come to the last step which is left. And then you are done with old threads, so that we go to new threads. I don't want to waste too much time with these threads. But if we don't finish today, we need one more round. I don't want to go there. I want to finish threads today. These threads, old threads. Okay, I'm again going to start summarizing. Now please look at the code with you so that your copy and my copy are not different. Okay. There are some fundamental ideas that you should remember. In any big program, we may need threads. I am summarizing very slowly. For running a thread, you need to create first a runnable class. Runnable class implements the runnable interface. Runnable interface has run method. That gives the body of what the runnable should be doing. And to create a thread, we must first create a runnable and then create the thread from the runnable. So let's now understand what is happening here. So we have a shared object. Shared object has two methods, inc and get, besides constructor. So inc increments the variable and get just displays the variable. Now both methods are marked synchronized. So what will happen? While the first thread is going on, now if I ask a simple question, let's see whether you can answer this. I said something gets locked. Can you guess what that something is? Who gets locked? Good. Who gets locked? See, there are three people in action, right? There is a producer, there is a consumer, and there is a shared object. Sorry, there is a fourth guy, main, test. So there are 4 people in action: shared, producer, consumer, and main. Now, when I call this, just go up, no? Now, when I am, most important guy is the shared object. Now, the shared object has a variable d and has 2 methods acting on it, inc and get. Inc is going to be called by one thread, get is going to be called by another thread. Is everybody clear up to that point? While inc is going on, get should not happen. While get is going on, inc should not happen. Why? Because these 2 threads should never collide. While one thread is doing its work, general programming practice is that we should not allow the second thread while it is working on one object. So while producer is working on shared, consumer should not be allowed to work on shared. How will you make that happen? The producer will lock shared and unlock it only after it is done. Same way, consumer, when it is calling get will try to take a lock. If it finds it's already locked, it will wait. And then it will continue. Now, what answer did we get when we run this? The producer only ran 3 times in that case. Produced 6, 7, 8. Consumer never got a chance to run. But one good thing has happened. While producer is running, consumer is not getting it. Why? Because producer is locking. Okay. Now, I am coming to the crux of synchronization. We have understood how to lock an object. We have understood how to create threads. We have understood how to pass that common object to threads. So we have come a long way. Now, okay, please listen with me very carefully. Okay, look at the inc method. Now the inc method locks the object, shared object, while it is doing the work. Now it locks it as soon as it enters because of the synchronized word. Then it says entered inc. Then it does that increment d is equal to d plus 1. Then it does exit inc. Now, as soon as the producer has produced this value, what should happen? Somehow, I should signal the consumer, hey consumer, I have produced something, you consume it, and after you have consumed it, you let me know, then I will produce the next value. I'm going to repeat this again. There has to be now some kind of signaling between these 2 threads such that the producer, when it produces something, it is able to convey to the consumer, hey, I have produced, now you consume. And the consumer, after it consumes, must be able to tell the producer, I am done, you are free to produce the next one. If we are able to do that, then our threading model is perfect. Then we can make threads act accordingly. We have only finished half of it. We have stopped him from coming while we are doing something. That's a good step. But now, that is not enough. That way, I am only producing. Consumer, poor guy, is getting starved. Only I am done, then he is getting an opportunity. That is not how it should be. Producer produces, consumer should be signaled. Consumer is signaled, consumer should consume, signal the producer. So it should be like that, the synchronization. Now, watch. So I am going to use a variable called flag. You have to get familiar with it because this is how the flag will work. So, now, I am going to talk about the code and then we are going to write it. So the shared variable is going to have a flag. The flag is initially 0. 0 means the producer should produce. That means the shared variable is empty or something. So flag is 0 means producer should produce, and it will make the flag 1. If the flag is 1, consumer cannot consume. Sorry, I am repeating again. I am going to use a flag. Flag is initially 0. The moment the producer produces, the flag will go up. Flag is gone up means what? Producer is done with production. Now it is the turn of the consumer. So the consumer will wait till the flag is 1. The moment the flag is 1, then only the consumer should consume. The consumer will consume, make the flag 0. Once the flag is 0, then only the producer gets the next chance to produce. So flag 0 means producer can produce. Flag 1 means consumer can consume. If we are able to do this, we are going to go home. We are going to do that. So I am going to create a variable, and it's not just flag. So we'll start with flag equal to 0. Okay, now look at the code. It's easier to explain after watching the code. So go to line 7, 8, whatever, either after that. No, let this line go up. Yeah. Now let's write. Now I'm going to write very carefully. This is a very critical code. Okay. While flag equal 0. No, equal 1. No. 1. Okay. The producer cannot produce. So the producer will do wait. Now we have introduced a different call. Okay. Now I am not done yet. We are writing very critical code. Watch carefully. While flag equal 1, that means the flag is 1. Till the flag is 1, producer has no work to do. Because producer should produce when the flag is 0. Till the flag is 1, producer simply pauses, waits, even though he is getting locked. Now, there is one small thing here, please understand. Suppose producer gets an opportunity to run, that is, it's able to lock the shared object. It gets in, it says entered ink, but it sees that the flag is 1. So it does wait. Now, silently wait will release the lock. Because if wait does not release the lock, the consumer can never run. Because it will find the object locked. So wait has 2 consequences. First consequence, it waits, the thread waits. Second consequence, the object is unlocked. The shared object is unlocked, because if it doesn't unlock, the consumer will never get a chance to make wait equal to 0. So wait releases the lock. That is important to remember. So now I came to line 10, means what? The flag was 1, then I would not have come out of this wait at all. I would have been waiting. So if I came to line 11, what does it mean? Unless the flag is 0, he will never reach line 11. Do you agree with me? He will never reach line 11 if the flag is 0. If the flag is 1. I'm sorry. If the flag is 1, he will perpetually remain in that loop. That is a very smart loop. Because he's releasing the lock also. And when he gets back, it will come back only when flag is equal to 0. Okay? There is a lot happening there. So, when it comes, it means, it comes here means what? Flag is 0. What should the producer do? Produce the value and raise the flag. So, he should produce the value That is what is happening on line 13. After that, after he has produced a value, he should make flag equal to 1, not 0, 1. Flag is 0 right now. He produced a value. Now he is raising the flag. I have produced, I am done. And he has to notify the consumer. So there is a call called notify. So we'll say notify. Okay. Now this notify is to say that I have done my work. If you are waiting, please come out of wait. Now here I am going to go through again. And then we will write the consumer and do something similar. Okay, one by one. I have entered ink. Who has entered ink? Please remember. So the producer entered ink. It locked the object because of synchronized. So shared object is locked under the control of the producer. Then what did the producer do? He said entered ink, fine. Then he saw, right now flag is 1. If flag is 1, the producer said I won't do anything. I'll go into a wait state and I will also release the lock. Because there's no point holding a lock now, because unless flag is 0, I can't work. Are you with me? Unless flag is 0, I can't work. So what flag is 1, why should I work? I will release the lock. So wait will release the lock. And the producer will go into hibernation. He'll go into idle state. Okay. Now till he gets a notification. Okay. Now he has not got notification. Acha. Now let's say flag was 0. Imagine flag was 0. If flag was 0, I will not go into wait state. Instead, what I will do? I will produce a new value. D is equal to D plus 1. I produced a new value. After having produced a new value, what did I do? I made the flag 1. I raised the flag. Flag is up means there is something there. I have raised the flag. I have one more responsibility. What should I do? I should notify the waiting consumer, because he may have gone into wait state because he saw a different flag. So I'll notify the consumer. Hey consumer, you get up now, wake up. Because I have made flag equal to 0, flag equal to 1, that means something is there, it's work for you. Okay, now this is what the producer will be doing. Now, can you visualize what will be the consumer? Lateral image. Okay, let's now go to the consumer. Okay, what should we do? What should the consumer wait for? If the flag is 0, consumer has no work. Flag is equal to 0 means nothing new has been produced. Are you with me? Flag is 0, nothing is produced new. Okay, because it is producer's turn. It's like a turn. They are managing their turn. Flag is 0, producer's turn. Flag is 1, consumer's turn. If flag is 0 and consumer is there, then consumer should say, I'll wait. So I'll say, while flag equal 0, then I will wait. Okay. So if the code reaches line 21, after line 21, if it reaches line 22, what does it mean about the flag? Flag is 1, not 0, 1. Flag is 1 means what? Producer has done his work. So the consumer can now consume the data. So it can do a get and it can retrieve the data. After that, what should it do? It should make flag equal to 1. No. If the consumer has consumed, it should make flag equal to 0. It should make flag 0. 0 means now tell the producer you are ready, consume, you can produce more. Okay, after this one more line. What? What? Notify. Notify who? Producer. Arey Baba, now I am done. You can produce another value. Okay. So notify. Okay. Now, I know I have gone very fast. Let's see it in action. Then you will understand what did we want to achieve, so that you have a sense of why we are doing all this. Okay. Let's just run it once. I hope you have enough to make a change. Okay, we are running it on the command line, so it doesn't matter. You can run it wherever. Okay, we'll run it. Let's observe what happens. Okay. Now, so let's try and analyze what happened. See, now the data has come correctly. Okay. The entered and the get, I think it's to them, because the wait and notify will confuse you. Okay, go back. I think we'll comment out the get, and because there is so much happening, we'll remove, they were there earlier just to illustrate mutual exclusion. We'll comment out the entered and exited, because they will not help understand. Okay, now we'll run it. Okay, now you see we get correct output. We don't lose 6, 7 or 8. Okay, now I am going to summarize again what is happening. Okay, now this is going to be, this is it. This is threads. Okay, threads 101. This is the end. Okay, if you have followed this much, you are done. Okay, but now let's try and understand what is happening. Okay, so okay, now you'll have to understand it's a bit of a tricky code, so you'll have to take it very carefully. What did it do now? If it is 1, I'll wait, but it is not 1, it is 0. In the beginning, remember, flag will be 0. So it said, okay, flag doesn't happen to be 1, so I will not wait. Instead, I will make flag now equal 1. And I will notify. Okay. Now, let's say, while this was going on, let's say the consumer got called and it called get. Now, imagine, while this was going on, this get was called. The get had a line while flag equal 0, wait. So if the consumer gets called first, what will happen? The flag is equal 0. Flag is equal to 0, which means that the consumer has no work to do, and rightly so. So it will go into a wait state. The consumer will just go into a wait state. It will suspend, not do anything, because if flag is 0, what should the consumer do? The consumer has no work to do. The producer has not done anything. So until the producer does something, consumer can't do anything. That is indicated by flag equal to 0. So if it finds that the flag is 0, it will wait. Okay, it will wait and release the lock. This happens if this guy by mistake got scheduled first. Anybody can get scheduled first. So let's say this goes first. So this guy ran first. So if this guy ran first, he looked at the flag, he found flag is equal to 0, but before that he had locked the object. Remember this get method itself, so the lock was here. So when it saw that the flag is 0, it went into wait state, and wait state removed the lock. The moment this guy goes into wait, the object gets unlocked. Okay. So then the producer, let's say, got an opportunity to run, and it saw that it first executed this line. Flag equal 1? No, flag is not equal to 1. So there is no need for the producer to go into a wait state. So what did the producer do? It incremented that D, made it 6 or something, made a flag equal to 1 and did notify. So now what, and the producer is done. Now if the producer is called again, let's say the loop is called again, what will happen? Now this flag will become important. Flag was set to 1. So the producer, if it sees flag is 1, he'll go into wait, he'll release the lock. Even if it gets called again, there's no danger. So even if the producer is called again and again, it will not produce anything because this flag will be 1. First time the flag is set to 1. So the flag is 1 until this flag is set to 0, which is the job of this guy. This guy cannot get called. So you see, using the flags, I am ensuring that until the consumer consumes, the producer doesn't get a chance to run. Or until the producer has produced, the consumer doesn't get a chance to run. So I have ensured that without this can't happen, meaning that the producer has to produce, then the consumer will consume, and until the consumer has consumed, the flag will remain 1. And if the flag is 1, the producer will not produce. So it is like saying, this guy will raise the flag, until the flag is down, this guy can't produce again. This is what this loop is guaranteed. Now you'll ask, okay, now an important question in people's mind will be, okay, can you go up? Okay, those of you who have thought so far with me will get a doubt, which is very natural. You know what doubt you should get? Why do I need synchronized? Can't I manage with just flags? While flag is 1, the producer will wait. And why do I need this synchronized? Why do I need this locking? I can manage with flags only. Make the flag 1. If the flag is 1 for the producer, allow the consumer to consume. Then make flag 1 in case I am getting a chance. So now it so happens that if I remove that synchronized word from there and try to do a wait won't work. Because the way Java has implemented it is, it says, I can use wait and notify only if you have taken locks. Unless you have synchronized, I will not support wait and notify. Because wait and notify needs lock to be there. Otherwise it will say I can't do anything. If you try removing the synchronized method, the synchronized word, the code, I think the code itself doesn't compile. Let's see. Or it will compile and not run. Okay, let's just watch what happens. Okay. So most probably it will give you an illegal state. No. You are not. You should not run without saving. Okay. Now, you cannot run, you cannot have a wait and notify without having the locks. This is the error you will get. You will get illegal monitor state exception. That is, you can't do a wait or you can't do a notify if you don't own the lock. Notify and wait both should be done only when you possess the lock. There's a precondition to that call. There's a reason for doing that. So now, if you see the code, if I bring back wait and notify, okay, I have to bring back synchronized, okay. Now what I will do is, just for variety, can you go down? Now, down, main. Some of you may have this doubt. See, I am always starting the producer first, so you may be thinking it is working because of that. Now I want to clear that doubt. It does not matter if the consumer is called first also, because of the flags. Okay, and the flags need wait and notify, which need synchronized. So now I have made a small change. I am saying the consumer gets called first. I mean, it just started first, so chance is that it will get called first. So watch that. No change. It will not disturb anything. Why? Because if the consumer gets called first, it sees that the flag is 0. If the flag is 0, that means the producer has not done its work. It will go into wait and release the lock. So the consumer automatically will get a chance. It will see the flag is 0 and produce data. Okay? So we'll give you this code also. Now I want you to look at this code carefully, study it at length, and we will do a couple of exercises on this, because this is an important area. In fact, okay, I'll just show you something. Okay, first we'll give you this. If you go to LeetCode is our de facto platform for practice, you know. In LeetCode there is a separate section of problems called concurrency problems. That is the importance. LeetCode believes that 3 skills are required for every programmer, computer science programmer. One is coding. Second is SQL, ability to write queries. Third is concurrent programming. All this what we are discussing comes under the beginning of concurrent programming. That's why OS has to be learned and this has to be learned. Now, there is a whole section in LeetCode which deals with concurrency problems, just concurrency. So we are going to do some of them so that you understand how to deal with concurrency. This is just the background. Okay, just see this. Okay, there will be quite a few. Okay. Well, not so many, but there are more in the hard category, I guess. Huh? These are all medium. Okay. Or most of them are medium. Now there is one easy. Too easy. Okay. Now I'm just going to show you, since we have time, one problem. Let's just look at one problem. So let's try and understand this question just for the heck of it. Okay. So we are given a class foo which is having 3 methods. First, second, third. I mean, they are not as elaborate as our producer consumer. They are simple methods. First, second, third. Okay. Then the same instance, okay, now read this. The same instance of foo will be passed to 3 threads. That means it's like our shared object. No, yes. Just like we created a shared object, and did we not give it to 3 threads? Here, no, we gave it to 2 threads. Here he is giving it to 3 threads. Doesn't change anything. So the same instance of foo will be passed to 3 threads. Thread A will call, thread A is going to call like here. Our producer thread was only calling INC. No, yes. And our other thread was calling, consumer thread was calling get. Here he is saying thread A will call first, thread B will call second, thread C will call third. Now comes the problem. Design a mechanism and modify the program to ensure second is executed after first and third is executed after second. Is it not similar to what we just did? That unless the producer produces, that is, unless inc is called, don't do get. Until get is over, don't do inc again. Same mechanism, asked differently. I have just picked a problem random. So how will you do this? So, what is he saying? Unless first is called, second should not be called. But the second thread will be coming earlier, you don't know. So what should it do? There are two ways of doing it. Okay. One way of doing it is, instead of using flag 1 and 0, you can make a flag which is 1, 2, 3. No, yes. So, for the second thread to execute, flag should be what? Hey, come on, think here. What is the condition? Condition is, first should come first, second should come second, third should come third. That is what they are saying, I am not saying. 3 threads should be there, working on the same shared object, like what we just did. Now what are they saying? Until first is called, second shouldn't be called. Until second is called, third should not be called. But you don't know threads. Threads work on their own thing. So you created threads. Any thread can come first. So what your logic will be? I already gave you a hint. Your flag should have 3 values. Let's say 1, 2 and 3. Okay, imagine. So, if you imagine thread 2 got called first, anything can happen. Should it run? It should run only if flag has become 1. Then only it should run. Otherwise it should wait. So, if 2 thread gets called and flag is either, depends on how you set it up, either 1 or 3, then it should wait. You are with me? And flag 1, when should it get called? If flag is 2 or flag is 3, it should wait. So we will start the object with flag equal to 1. If flag happens to be 2 or 3, flag 1 will not do anything, it will wait. Yes, no? Okay. That will solve this. Want to give it now or? No, I think we are running short of time. So this is the kind of problems we have to do. Okay. There are many. So at least we'll do 4 or 5 in the next session, so that you know how to deal with threads. So my suggestion will be, before you come for the next session, go through the code which we just gave you, the new one. Okay, I'm writing it here also. Okay, day 15, not 16. Day 15, Java Lab 3. That is the name under which we have given you the code. This is the final version with the shared variable, flag, all that. So please try and understand this code. In the next session, we are not going to teach anything new. We are going to do about 2 or 3 problems depending on your ability. Analyze those problems. We are going to pick up from lead code only and do about 3 or 4 problems so that you know what is concurrency and you understand concurrent programming. This is easy, huh? Medium, okay. So they will give you some code like this. There is a class called foobar. It has a method foo, which is printing 10 times foo, and bar. Okay, there are 2 methods in this class. Then first thread is calling foo, second thread is calling bar, like put and get, or produce, ink and get, like that. So thread A will call foo, thread B will call bar. Output should always come foo bar. Exactly what we did now. Are you understanding? It should never happen foo or bar or foo bar. No. It should be foo bar. The synchronization. No, yes. Don't you think it is very similar to what we did just now? No? All of you are convinced? Very similar. We have to use flags, we have to use shared object to both. This object has to go to both, 2 threads. Okay? Yeah, this is, answer should always come, foo bar. And then it should take an n as a parameter that decides how many times it should run, like our loop. Just now we also had a loop, no, it ran so many times. So that n should come as a parameter. So this is another kind of concurrency problem. Then, okay, let's see if we can give you a build H2O. Okay, so here are another questions. There are 2 kinds of threads, oxygen and hydrogen. Your goal is to group these threads to form, this is interesting. You know what it's doing? There is a hydrogen thread and an oxygen thread. How the synchronization should happen? 2 hydrogens, 1 oxygen. So there are going to be 3 threads. 2 hydrogen threads and 1 oxygen thread. Output should come what? Hydrogen, hydrogen, oxygen. Again hydrogen, hydrogen, oxygen. So you have to manage your flags, wait and notify accordingly. You have to be a little more smart. Okay. Just a little variation. Okay. These are the kind of problems we need to solve. You should be able to solve. Then only you know threads. So to do that, to get here, that's why I covered this fast. Please revise this and come. Try and understand as much. Once you do this, you will understand this better. Okay? You can do this. All of these you can do. And this is what you should do. Stop here.